Okay, this is 8.5. E is in echo, trigonometry. We're starting on example 4, graphing a polar equation. Now notice it's called a cardioid. Comes from the Latin cardi, which means heart, so it's kind of, the graph of this looks kind of heart-shaped. Alright, so what we've got here is r equals 1 plus the cosine of theta. Alright, so one of the ways you can tell that this is heart-shaped is if you look on page 366, it gives you many of the different graphs that you're going to graph. Now notice the heart-shaped graph in the middle, limacons. Notice what the r equals. A number plus or minus a sine or a cosine, and that's what we have here. We have a number plus or minus a sine or a cosine. So that means when we get done with this, it's going to look like one of those graphs there. Okay, and you can also tell which graph it's going to look like by underneath each one. Notice the first one says if the number, or if letter A, which is this one, over B, which is the number in front of here, which is 1, so 1 over 1, if that is less than 1, it's going to look like that graph. If it is equal to 1, which it is, 1 over 1 is 1, it's going to look like that second. So it's going to look more like, kind of like that, well, a sideways heart-shaped thing. Okay, that's what it's going to look like. So that's what I'm expecting this one to look like. Alright, so let's go back and see what we've got here. So to graph this equation, we're going to look from some ordered pairs and connect the points. So we're going to make a graph. So we're going to start with theta, and you've done this before. We're going to start with theta. Just start picking angles. 0, 30, about ready to throw this pen away. Alright, so try it again. It's just not, I think it's just wore out. 0, 30, 45, just the ones that you're kind of the most common with, 90, 120, and we'll just stop there. Alright, so the cosine, let's draw a line here. The cosine of each one of these, like the cosine of 0 is 1, cosine of 30 is 0.9, because we're just doing everything in decimal here. We don't need the radicals because we're going to graph it. It's harder to graph a radical than it is a decimal. And cosine of 90 is 0, cosine of 120 is negative 0.5. Okay, so that's that part. Now we're going to add 1. Cosine of theta plus 1. So 1 plus 1 is 2. 1 plus 1, 0.9, or 0.9, 1 plus 0.7, 1 plus 0.5, 1 plus 0, 1 plus negative 0.5. It's going to give me that. Okay, so this is what I need, and this is what I need, because this is equal to r. So remember, when we're graphing, we're looking for r, and we're looking for theta. Okay, so here's my r's, and here's my thetas. So I'm just going to correspond those. So if I go and get my graph, let's go ahead and graph these. So 0 and 2. So at the point 0 degrees and 2, I'm about right there. So it's going to be a little bit hard because it's so small, but there's my 0 degrees and my 2 long. Now I've got a 30 degree, and it's 1.9 long. So 30 degrees, and it's about right there, not quite 2. And then I go 45 degrees, 1.7 long. So I go up 45 degrees, and I go 1.7. And I just keep graphing until I end up getting something that looks like that. So notice I only went up to 120. So that's only going to give me to 120. So I got that shape, but I know according to the book where I looked to see what this was going to look like, that it's going to do the same thing over here. In fact, I might want to try 180 just to see what happens. And when I put the angle 180 in there, I get for my R value, I get 0. So that's why it sucked back in to 0 right there. But that's what it's going to look like. So it's just putting in some numbers, just like we did over here. There's theta. And then we take the cosine of theta plus 1, and that's to find what my R equals, because R equals whatever this is. And so that's why I went to this direction. So here's my R's, here's my thetas. In fact, if I wanted to write that first one, it would be R 0 degrees. My next one would be 1.9, 30 degrees. Okay, so see what happens there? So it's just doing that over and over and over. Now when they give you example 5, example 6, example 7, they're all the same. They're giving you different designs in the graph, but you're doing them the exact same way. And I would make good use, the book doesn't really refer to it a whole lot, but I would make good use of page 366 and look at what you're getting. So if you look at, example 5. In fact, let's just write it down. We're not going to do it because it's just like the one we just did. You're just going to get a different graph here. Let me get rid of some of my junk here. And number 5 says that R equals 3 cosine of 2 theta. Alright, so let's look at 366 and see what the heck that is. Okay, so let's see here, a problem that has a number in front of the cosine. A number in front of the cosine would be the bottom row, second and third over. And then it also says that there's a number in front of theta. Okay, so it's going to look like either the second or third one. It's called a Rose curve, but which one is it going to be? Well, it says that if this number right there is 4, it's going to look like the second one. If that number there is 3, it's going to look like that one, the third one. If this number is a 2, it's going to look like the first one. But because it's a cosine instead of a sine, instead of it looking like this, when you're all done, it's going to be shifted to actually look like this. So even though it's a cosine, it's still going to give you that rose look. It's just going to be up and down instead of like at the 45-degree angle like the red one. But at least it gives you a picture of what it looks like, so when you're starting to graph it, you can graph one of those rose loops and then go from there. So anyway, we will continue on with 8.5F in our next video.